We've covered Discover for data exploration, but understanding trends, anomalies, or patterns from numbers and text alone can be challenging. Let's explore visualizations for presenting data in more comprehensible formats. We'll start by introducing aggregation-based visualizations. After this lesson, you'll be able to create aggregation-based visualizations for security use cases, recognize the different types, identify best practices, construct an aggregation-based visualization, and interpret that data. Scrolling through documents line by line in Discover makes it difficult for humans to absorb anything of value. It would be hard to draw conclusions or absorb data quickly and efficiently. Visualizations make it easier to interpret complex data by presenting it in graphical formats like bar charts, line graphs, pie charts, heat maps, and more. This visual representation allows users to quickly spot trends, patterns, outliers, and correlations that may be harder to identify in raw document tables. Aggregations allow you to group and analyze data in various ways, such as by count, average, sum, minimum, and maximum. These aggregations form the basis for most of the visualizations that you create in Kibana. This could help us answer questions like which internal IP is my top talker or what's the average amount of bytes across my network. Aggregations can be grouped into buckets where we can slice the data or metrics where we can compute a numeric value. Metric aggregations calculate numeric values over document sets, similar to a pivot table's summary of a column. These mathematical functions include count, which is the default metric aggregation that counts document hits based on the index pattern and date range, sum, unique count, average, minimum, and maximum, and multiple values with percentiles. Consider this spreadsheet example with ID number, user, age, country, and category fields. Think of some metrics that we can use on this spreadsheet. We might ask, how many users are there, which is a count metric, or we can ask what is their average age. Since there are numerical values in the age column, we can use the metric aggregation of average for the age. Now with the pivot table, we can see that the average age of those users is 34. Bucket aggregations group documents into buckets based on field values, ranges, or other common criteria. We are slicing that data. For example, we can aggregate on network.transport field, and that's going to give me results of the transport layer traffic, whether it be UDP or TCP. We can aggregate on event.dataset fields, and that's going to give me the results of the Zeek logs, whether it be CON, DNS, or HTTP. In addition to the buckets themselves, the bucket aggregations also compute and return the number of documents. That's called the doc count. That's going to fall into each bucket, and that's going to be the default metric. In this example, we want to divide the data by each category and determine how many times those values occur within the data. Category would be the field name, and the bucket would be the values. I would have a bucket for A and a bucket for B. Within the buckets, we are doing a metric of count. How many occur of each? Here we can see we have a count of 3 for A and a count of 3 for B. There are many visualization types available to view our data, with metrics and buckets applied. One of those is a simple bar chart. This is counting the number of documents for each Zeek log type. On the x-axis, we have the bucket aggregation where we're using the field name of event.dataset as a category, and then the values are going to be CON, DNS, and TLS that fall into their own buckets. Then, on the y-axis, we have the metrics aggregation where we are counting how many documents are in each bucket. It looks like we have 4 documents for CON, 1 for DNS, and 1 for TLS. We can further slice and dice our data with sub-bucket aggregations. Taking the same buckets from the previous bar chart of CON, DNS, and TLS, we add a sub-bucket aggregation of the transport layer protocol. UDP that's going to be represented as orange, and then TCP represented as teal. Within the CON log, how many documents are UDP, and then how many documents are TCP? It looks like we have 2 documents, UDP, and then 2 documents, TCP. For DNS, that's 1 UDP, and TLS, that's 1 TCP document. There are many visualization types available to us, and not all of these are going to be useful for security analytics. Now data tables would be good for quickly seeing the most common or least common values. Bar and line charts would be good for seeing data over time and then seeing spikes in our data, but feel free to experiment and see what works and makes sense to you. This brings us to our demo for aggregation-based visualizations. Let's switch over to Kibana. We've been using the Discover app in Kibana. Now we're going to switch gears and go to Visualizations. To do that, go to the hamburger menu and select Visualize Library under Analytics. Within the Visualize library, you will see already created visualizations, but we're going to create a new one by choosing Aggregation-Based and Data Table. Select ECS-TAC Zeek Index Pattern for Zeek logs and Day 0 for the time picker. The default metric shows the document count in your Zeek index pattern on Day 0. Let's create a data table with source IP and source bytes. To do that, under Buckets, add split rows with terms aggregation. Select the source.ip field. Default ordering is descending, keep the default size. After updating, the visualization shows the top 5 source IPs with .54 leading at 39,193 counts. Let's say that I wanted to change this to see my top 10. To see the top 10, return to the Buckets window, change the size to 10, and update the visualization. You can sort columns ascending or descending with them currently showing the highest to lowest count. Ascending would show 265 down to 39,193. Let's set sort back to descending. Now .54 is back at the top with an account of 39,193. Make it interesting by adding queries and filters. Investigating a suspicious external IP. Query its destination IP to find internal sources communicating with it. This shows one internal source IP responsible for all communications. Let's clear this and update to get back to the top 10 source IPs. Now you will learn how to change the metric. To modify the metric aggregation from count to sum of source bytes, expand the metric section, change from count to sum. Select source.bytes as the field and click Update. The visualization now shows the top 10 source IPs with the highest total originating bytes. You can adjust rows per page in the Options tab. Setting it to 5 rows creates 2 pages to view all 10 top source IPs. To create subbuckets, you can create a new data table, add split rows under buckets, select terms aggregation, choose event.dataset as the field, and leave the default at 5 and update. This shows the top 5 Zeek logs from Day 0, with con log showing 31,972 counts. For a further breakdown, you can add another subbucket with split rows, use terms aggregation, split by network.transport, and update to view UDP and TCP connections per log. To save, click Save in the toolbar, name it Top 5 Zeek Logs by Transport Protocol, select None under Dashboard Options, and save to the library. Let's review what we covered in the demo. Buckets are going to allow you to split data based on a field or terms aggregation. In this example, we're using the bucket aggregation to get a count of our source IPs. Split rows are going to have each row be a different source IP. The default metric for visualizations is count the total number of records. Here we count the total number of records for each source IP. For metric aggregations, we can use a variety of math functions against the values in a specified field. In this example, we chose source.bytes, and then we're using the sum aggregation, and we are seeing how many bytes were sent by each source IP address. There are different metric aggregations we can use, such as average, maximum, median, and min. Here is an example of a subbucket aggregation. Just remember, subbuckets are going to divide buckets into smaller groupings. The main bucket here would be the zeek.http.origin. That's your header of the HTTP request. This is getting the count of documents within this field. We have 2,319 documents for the hill.com. Now when we add a subbucket within the HTTP origin field, let's say I want to see the response status codes. This is going to allow us to display the individual HTTP status codes per the origin request. Doing this shows a status code of 200 for the site, thehill.com. This had the highest number of documents.